Now let's look a little bit about project characteristics. They can be single unit, many related activities. They can be difficult production, planning, and inventory control, general purpose equipment, and high labor skills. Examples of projects include building constructions, research projects. Now, when we look at the management of projects, as we previously stated in the class, management, we have planning, organizing, leading, controlling. In project management, we also put in the concept of scheduling. Now, in the planning phase, we look at goal setting, defining the project, and team organizations. In the scheduling, we relate people, money, and supplies to specific activities and activities to each other. Controlling is monitoring resources, cost, quality, and budgets. We revise plans and shift resources to meet time and cost demands. Now, in the planning part, we set up objectives, we identify the resources, we break down structures, and we develop the organizations. In the scheduling, we project activities. We start and end times development. We identify what the start times are and what are the end times. There's other more times that we have to consider, which we will go into as we move on through today's session. And then, of course, the network itself. In the controlling, we use the monitoring, comparing, revising, and various actions that we do. And of course, we have to, when you do the controlling and you compare it, you find any issues, you have to rectify them. In project planning, we have to establish the objectives. If you fail to establish the objective, your plan tends to wander. Consequently, this is highly important because wandering projects cost more money. We also have to define the project. This may seem simple, but it is not. Projects may be a terminology for one person, while it's something else for somebody else. So when you're doing, especially in construction projects, you have to ask the people, what exactly are they envisioning? What is it that they look at? Define it. Put it in writing, because if it's not in writing, they're subject to debate. Create the work breakdown structure. Determine the resources needed to accomplish the task, and of course the related costs associated with it. And you form the organization to create to initiate the project. Projects are often temporary in nature, right? So when we do construction projects, they are temporary in the sense that once you finish, the project is completed. We use specialists for entire company. It's usually headed by a project manager, and that handles the coordination of the activities, monitors the schedules and costs, and of course, a permanent structure is called a matrix organization. So don't get confused between a matrix organization and a project. The difference between the two, and the only difference between the two, is that the matrix organization is permanent. It's continuous, ongoing. The project itself is short-lived. Work can be defined with a specific goal and deadline. It's important to do that because that way it doesn't go on forever, and then it becomes a matrix organization. The job is unique or somewhat unfamiliar to the existing organization. The work contains complex interrelated tasks requiring specialized skills. The project is temporary but critical to the organization. The project cuts across organizational lines. Now, the role of a project manager are being highly visible and is responsible for making sure that all necessary activities are finished in order and on time. This is a monumental task. The project comes in within budget. That's another monumental task. Hint, the less change orders you have in the project, the less times you'll have to go to management to ask for more money. Every time you do a change order, it costs money. The project meets quality goals. The people assigned to the project receive motivation, direction, and information. Project managers should be good coaches, good communicators, able to organize activities from a variety of disciplines. Now let's discuss some ethical issues on this subject. Project managers face many ethical decisions on a daily basis. The Project Management Institute has established an ethical code to deal with problems such as offers of gifts from contractors, pressure to alter status report to mask delays, false reports to charge off time and expenses, pressure to compromise quality to meet schedules. Let us look at the concept of work breakdown structures. It's always in levels. You have the first level, which is the project, followed by the second level, which is a major task in the project that needs to be completed, followed by a third level, which is a subtask of the major task that needs to be completed, and then the fourth one is the activities, or the work packages to be completed. There could be even further breakdowns down, but those four categories are good. For example, in level 1, you could develop, if the project itself could be developing Windows 8 operating system. It then breaks down to a level 2, but in there you develop it into a breakdown structure of software design, that's one subset, cost management plan, that's a second subset, and system testing, that's a third subset of level 2. Then we go to level 3, you're developing the GUIs, systems, design cost tracking reports, module testing, defect testings, and on and on and on. And these are aligned with the 3: software design, cost management plan, and system testing of level 2. Thus, level 3 is aligned with level 2, which is aligned with level 1. And the same goes on for level 4, aligned with the level 3, the 2, and the 1. Now, there's some project scheduling techniques. The first is you ensure that all activities are planned for. The second is their order of performance is accounted for. The third is the activity time estimates are recorded, and the overall project time is developed. The purposes of scheduling include showing the relationship of each activity to others and to the whole project. It identifies the precedence relationship among activities. It encourages the setting of a realistic time and cost estimate for each activity. It helps make better use of people, money, and material resources by identifying critical bottlenecks in a project. Project management techniques include the Gantt chart, critical path method, and program evaluation and review techniques, also known as PERT. A simple Gantt chart is basically a design whereby on the left-hand side of your Gantt chart itself is the various attributes you are monitoring or you are scheduling. And then there is the time that goes across at the top. The Gantt chart shows a block of time that is designed for each one of the segments on the left-hand column. Consequently, you'll have overlapping time schedules, etc. So you'll know when these actions have to be completed. When is the beginning time, when is the end time, and when is the period that it is active. Also, when it's not active. One example could be service for, let's say, a Delta jet. Passengers are deplaning, so that's when do they get off. Baggage claim, that's a period of time when they're doing it. The baggage containers are offloaded from the aircraft. The fueling, the pumping of the fuel, the engine injection waters, and on, how long that period is going to take. And the period of time, by the way, it's in minutes. So you'll see that there's a whole bunch of tracking mechanisms that go along, and they're all interrelated. Some can be done during, some can be done before, some can be done immediately or a long time after. The key is to identify the block of time that is needed and assign the period of time within the matrix. Now, project controlling is when you closely monitor resources, costs, quality, and budgets. Feedback enables revising the project plan and shifting the resources as needed. Computerized tools produce extensive reports that allow management to understand where the gaps or failures may be occurring. Project management softwares include Oracle Primavera, MindView, HP Project, Fast Track, and of course, the one I use the most is Microsoft Project. Project control reports include detailed cost breakdown for each tasks, in some cases, even the subtask of subtasks. The second is labor requirements with allocated cost and hour summaries. Raw materials and expenditure forecasts. Then there's the variance reports, time analysis report, and work status reports. Let's go over a little bit about PERT and CPM. The 6 steps of PERT and CPM are define the project and prepare the work breakdown structure, just like we mentioned just recently. Develop relationships among the activities. Decide which activity must precede and which must follow the other. This will save you time in the long run. Draw the network connecting all of the activities. Those are the usual circles and dots with key numbers within the circle and the lines connecting the circles having a value in some cases, with the arrow pointing to the specified direction of the flow. The fourth is assign time and or cost estimates to each activity. The fifth is compute the longest time path through the network. This is called the critical path. Thus, the longest time path through the network is called the critical path. This is key for you to understand and know. Use the network to help plan, schedule, monitor, and of course control the project. Questions regarding PERT and CPM that can be answered by these tools. When will the entire project be completed? What are the critical activities or tasks in the project? Which are the non-critical activities? What is the probability the project will complete by its specific date? Is the project on schedule? Is it behind schedule or is it ahead of schedule? Is the money spent equal to, less than, or greater than what was budgeted? Are there enough resources available to finish the project on time? If the project must be finished in a shorter time, what is the way to accomplish this at least cost? Now, there's a concept known as analysis on node. And here is where, remember those little circles I spoke about before that have lines attaching each one and all that? Well, the activity is the node. So you can do activity on the node or activity on the line. So the activity, in this case, we're going to go on the node. And a brief description is a matrix format that has a table system. In this particular case, let us assume that we look at your table 3.1, that is chapter 3, table 3.1 of your textbook, where it is the Milwaukee paper manufacturing activities and predecessors. Again, that's table 3.1. You will see when you open there that you have 3 columns. One is activity A through H, then you have descriptions of each, and then you have the immediate predecessor. We'll only describe the first 3. Activity A is build internal components and it has no predecessor. Activity B is modify roof and floor and it has no predecessor. Therefore, those 2 nodes or activities, A and B, by not having any predecessors, let us consider those the starting nodes. Now you have C. Activity C is construct collection stack. Well, that has that predecessor. The immediate predecessor is A. So there should be a line connecting A to C. And so on and so on. Now, we determined the project schedule itself. We performed what's called a critical path analysis. Now remember, I told you previously that the critical path is the longest path through the network. The critical path is the shortest time in which the project can be completed. So there's 2 things in there. The critical path is the longest path through the network and the one with the shortest time in which the project can be completed. Don't get confused. Any delay in critical path activity delays the project, and hence the term critical. Critical path activities have no slack time. So if you have a critical path, it has no slack time. Why is this important? Because you're going to be computing the slack time to identify how much slack is available in the projects, in certain segments of the project. Now, we look at then back to table 3.2 of your textbook where it says time estimates for Milwaukee paper manufacturing. Let us look at the first three activities again. And activity A, build internal components. Time in weeks is 2. Activity B, modify roof and floor, is 3 weeks. And C, construct collection stacks, is 2 weeks. There are a whole other set of activities all the way down to H. When you sum all of those up, all the activities A through H is 25. Again, don't get confused. I only described A, B, and C. If you add those 3 up, all you get is 7. But in reality, it goes all the way to H, which gives you a total time in weeks of 25 weeks for the project itself. So, to perform a critical path method, you have to identify what the earliest start time is, also known as ES, earliest time at which an activity can start, assuming all predecessors have been completed. Earliest finish is the time at which an activity can be finished. The latest start is the time at which an activity can start so as not to delay the completion time of the entire project. And the latest finish is the time by which an activity has to be finished so as not to delay the completion time of the entire project. The activity format in itself is when you look at those nodes, there is a color pattern within the nodes, and it's divided into 4 quadrants and a central quarter. The central quarter usually has the activity name or symbol with the activity duration in the bottom. In other words, the activity symbol would go in the central quarter top and the activity duration in the bottom. So let us look at A. So the activity's name of the symbol is A, and the activity duration, remember, it was 2 weeks. It goes 2 in the bottom. On the upper left-hand section, you'll have the earliest start time, or ES, and on the upper right-hand section, you'll have the earliest finish, or EF. In the lower left-hand side, you'll have the latest start, or LS, and on the right lower section, you'll have the latest finish, or LF. When we do a forward pass calculation, we begin at the starting event and work forward. That's why I say forward pass. The earliest start time rule, if an activity has only a single immediate predecessor, its earliest start time equals its earliest finish time of the predecessor. If an activity center has multiple immediate predecessors, its ES is the maximum of all the EF's values of its predecessor. Make sense? Good. ES then equals the maximum amount of EF of all immediate predecessors, whether it's one or multiple EFs. We begin the forward pass at starting event and work forward. So the earliest finish time rule is the earliest finish time, EF, of an activity is the sum of its earliest start time, ES, and its activity time. EF equals ES plus activity time. The backward pass begins with the last event and works backwards. Latest finish time rule is if an activity is an immediate predecessor for just a single activity, its LF, latest finish time, equals the latest start of the activity that immediately follows it. If an activity is immediate predecessor to more than one activity, its LF is the minimum of the LS values of all activities that immediately follow it. Consequently, latest finish time is the minimum of the late start of all immediate predecessors following the activities, or not predecessors, followers of the activity. Therefore, LS equals LF minus activity time. I say again, LS, latest start time, equals latest finish time minus activity time. Now let's look at computing the slack time. After computing the early start, early finish, late start, and late finish time for all activities, you compute the slack or free time for each of the activity. Slack is the length of time an activity can be delayed without delaying the entire project. That's why it's important for you to know these. Slack is equal to LS, late start, minus ES, early start. Or slack is also equal latest finish minus early finish. Now, when we have the matrix again, you will see that in your book, you were given an example of how to develop this. So activities with zero slack are on the critical path. It starts at the first activity in the project, terminates at the last activity in the project, and includes only critical activities. Consequently, slack is 0. So let us look at activity A. The earliest start would be 0 because it's the start time itself. Earliest finish is 2 weeks. The latest start is 0, and the latest finish is 2 weeks. Therefore, 2 minus 2, which is LS minus ES, is 0. All right, so I'm sorry, it's LS, which is 0, minus ES, which is also 0, is 0. Is it on the critical path? Yes. Let's look at B. B, the early start is 0, the earliest finish is 3, the latest start is 1, and the latest finish is 4. So if we go ahead and have the LS, all right, which is 1, or in this case, latest finish, I'm sorry, LS, latest start is 1. Earliest start is 0. So when you subtract, you have a 1. Is that in the critical path? No, because it's not 0. And then lastly, let us look at C. Earliest start, 2. Earliest finish, 4. Latest start, 2. Latest finish, 4. So when we look at the latest start, that would be 2. Earliest start, that would be 2. 2 from 2 is 0. Is that on the critical path? Yes. So that is one way you identify critical path. It helps you, and it also allows you to corroborate with management that you have thought through this. Now you can also develop the early start minus early finish Gantt chart for any project. So that's one of the things you might end up to do. And then you also are going to do the late start and late finish Gantt chart. You want to program that out through time. Variability in activity times includes, the CPM assumes we know a fixed time estimate for each activity, and there is no variability in the activity time. PERT uses a probability distribution for activity times to allow for variability. So when you're doing a CPM, there is no variability in activity times. PERT, on the other hand, does allow you some flexibility in variability. 3 times estimates are required for these. There's the optimistic time, which is A. If everything goes according to plan, that is the optimistic. There's the pessimistic time, or B. It assumes very unfavorable conditions. And most likely time, M. Most realistic estimate. These are the 3 variables that you will need in order to compute the variability in activity. These follow an estimate or following the estimate of a beta distribution. What is a beta distribution? It could be a 0 or a 1, where A is 0, B is 1, or on and on and on. In this case, it's one or the other. So A would be the optimistic time, B the pessimistic time, M the most likely time. The formula would end up being for the expected activity time, T for time, equals, in parentheses, A, which is your optimistic time, plus 4 times your most likely time, plus B, which is the pessimistic time, close parentheses, divided by 6. Why 6? Well, A is 1, 4M is 5, and then B is number 6. You're trying to go ahead and make sure that you have 100%. The variance of activity completion time would be V for variance equals, in brackets, parentheses B, right, that's the pessimistic time, minus A, the optimistic time, close parentheses, divided by 6. Again, 6 because there's the 6 beta times. And you close the brackets and you put that to square. You square that to take out the negatives. This would give you a shaped curve, bell-shaped curve, right? With, in this case, the one that's in the book in figure 3.11 would end up having a kurtosis to the right. That's, the sloping goes a little bit more kurtosis to the right. So in this particular case, if you look at 3.11, you have the optimistic time A all the way to the left, which means the shorter period, and the pessimistic time all the way to the right, which is the pessimistic time of activity. So your probability of 1 in 100 of less than or A, of AE occurring is on the all the way to the left extreme. And if you look at the probability of 1 in 100 of A being greater than B, it occurs to the extreme right. That's why it's important for you to understand to use these. So when you compute the variance, I refer you to table 3.4 of the textbook, and you'll have activities where you have the pessimistic, which is the alpha, most likely the M, the pessimistic or the B, and your expected time, which is the T, equals parentheses A plus 4M plus B close parentheses divided by 6, and of course the variance, which I already described previously. And you get those. And that way you start looking at each one of the activities where you have the expected time and variance of each. And it gives you a good description of how things are going to be going. Let us now enter the world of forecasting models. By this time, I suggest you take a deep breath because I just did a lot of information to you. So, but it's important that we keep going so that we can complete our session today. Forecasting. What exactly is forecasting? Is it a process of predicting the future? Do you have a small crystal ball there and look at it and all that? In some cases, because we're using stochastic modeling, that is basically we are doing computations of statistical analysis, it is because we have assumptions. We make predictions based on assumptions because we don't have perfect information, or at least we think we don't. Underlying bases of all business decisions include production, inventory, personnel, and facilities. Forecasting time horizons include short-range forecasts, which is up to a year. Generally, it's less than 3 months, such as purchasing, job scheduling, workforce levels, job assignments, production levels, etc. The medium-range forecast is between 3 months to a year. And these are sales and production planning, budgeting cycles, etc. Now, if you're in the world of federal government, sometimes it goes all the way to 7 years, even though you forecast the budgeting cycle using the PPPM system, planning programming budgeting system, PPPS. It sometimes doesn't get that way. Congress gets in the way. So the next one is long-range forecasting, which is 3+ years. New product planning, facility location, research, and development. Let's look at some distinguishing differences. Medium long-range forecasts deal more with comprehensive issues to support management decisions regarding planning and product plans and processes. Short-term forecasting usually employs different methodologies than long-term forecasting. Short-term forecast tends to be more accurate than long-term forecast. Let's look at some of the influence of the product life cycle. There's the introduction, there's the growth, there's the maturity, and then there's the decline of the product. Introduction and growth requires longer forecasting than maturity and decline. As product passes through life cycles, the forecasts are useful in projecting staffing levels, inventory levels, and factory capacity because you have some information available to you at that time. Types of forecasting include economic forecasting, such as addressing business cycle, inflation rate, money supply, housing starts, etc. I look at economic forecasts all the time on a daily basis because of inherently being the chairman of the board of a federal credit union, I am required to understand these concepts of business cycles and especially the inflationary rate, which is slowing up, slowly going up because it affects the prime rate. Because the Federal Reserve Board, by increasing its Fed rate, will go ahead and impact the money, the actual interest rates that I charge for loans and housing starts, etc. Money supply is just basically the treasury, but you'll know that in economics where you have the M1, the M2, the M3, M4, and then M standing for money and supplies. But we won't go into that. Technological forecast is the second type. These predict the rates of technological progress. It impacts development of new products, new softwares coming out. That'll determine how much change you need to do in your product design. Demand forecasts include predict sales of existing products and services. The strategic importance of forecasting includes supply chain management, which good supplier relationships, advantage in product innovation, and cost and speed of market will help. The human resources segment of hiring, training, and laying off employees. And of course, capacity. Capacity shortage can result in undependable delivery, loss of customers, and of course, loss of market share. There are 7 steps to forecasting. Determine the use of the forecast. Select the items to be forecasted. Determine the time horizon of the forecast. Select the forecasting model or models. You can use multiple. Gather the data needed to make the forecast. You make the forecast and then you validate or implement the results. Let me give you some realities though. Forecasts are seldom perfect. Unpredictable outside factors may impact the forecast. Most techniques assume the underlying stability in the system, and product family and aggregate forecasts are more accurate than individual product forecasts. Now let's look at some forecasting approaches such as qualitative methods. When is that used? Well, it's used when the situation is vague and little data exists. For example, new products, new technology. It involves intuition, experience. For example, forecasting sales on the internet. On the other hand, quantitative methods are used when situations are stable and historical data exists. Existing products and current technology are 2 bases for it. It involves mathematical techniques. For example, forecasting sales of color televisions. Let us overview the qualitative methods. There's a thing called the jury of executive opinion. You pull opinions of high-level experts, sometimes augmented by statistical models. And there's the famous Delphi method. You may hear a lot of people talk about that one day. These are panel of experts queried interrelatively. All right, so they're queried in form, in sequence, and in entire panel. So there are groups and there's individuality and interactivity. They're interacting with each other. Right? The individual ones would interact across the internet, etc., because they're each one individually, but they're actually talking in a group using software systems. The Salesforce composite estimates from individual salespeople that are reviewed for reasonableness, then aggregated together. And then, of course, the famous market surveys. This is where you ask the customer. When we talk about jury of executive opinion, it involves small groups of high-level experts and managers. Groups estimate demands by working together. Combines managerial experience with statistical models. It's relatively quick, that's why people like it, and it's a group think disadvantage though, because one can sway the other inside the formality, especially if one happens to be the boss. The Delphi method is iterative group process, continuing until consensus is reached. That means it keeps going and going until they give up. It's almost like a jury. 3 types of participants: the decision makers, the staff, and the respondents. Right? The decision makers evaluate responses and make decisions. Right? The staff administrates the survey, and the respondents are the ones that make the valuable judgments. The Salesforce composite includes each salesperson projects his or her sales. Combined at district and national levels, the sales rep know the customer's wants, therefore they have a better understanding of what it is that they can do. And maybe a little bit overly optimistic. Be careful with that. Market surveys ask customers about purchasing plan, useful for demand and product design and planning. What consumers say and what they actually do may be different. It also may be a bit over-optimistic. Now let's look at the quantitative approaches. The first 4 that I'll be talking about are called the naive approach, or correction, the time series models. So the first 4 are called the time series models, which include the naive report, moving averages, exponential smoothing, and trend projection. The last one is the associate model, which of course is my all-time favorite, the linear regression model. Yeah, you can, by now you have figured out that I am a mathematic geek. But aside from that, let's move forward. Time series forecasting. It sets off evenly spaced numerical data. It's obtained by observing response variables at regular time periods. Forecast based only on past values, no other variables are important. It assumes that factors influencing the past and present will continue influencing the future, which may not be totally correct, but that's an assumption that is imperative. When we look at the time series components, we look at trend, seasonal, cyclical, or random. The trend component is persistent, overall upward or downward pattern. Changes due to population, technology, age, culture, etc. Typically several years in duration. Seasonal components are regular patterns of up and down fluctuation due to weather, customs, etc. It occurs within a single year. Cyclical components are repeating up and down movements affected by business cycle, political, or economic factors. Multiple years in duration and often causal or associative in relationship. The random component is erratic, unsystematic, residual fluctuations occur. It's due to random variation or unforeseen events. It's short duration and it's non-repeating. Now let's look at the naive approach. The naive approach assumes demand in the next period is the same as the demand in most recent period. Hence, why we call it the naive approach. For example, if January sales were 68, then February sales will be a 68. Sometimes cost-effective and efficient, and can be a good starting point if you have no information. The moving averages is a series of arithmetic means. Means is another word for average. It used in little or no trend. Used often for smoothing. It provides overall impression of data over time. Consequently, the moving average formula is moving average is the sum of demand in previous n periods divided by the n. That is one of the simplest formulas out there. It increasing n smooths the forecast but makes it less sensitive to change. Does not forecast trend well and requires extensive historical data. That's the problem with the moving average. Exponential smoothing are a form of weighted moving averages. These weights decline exponentially. Most recent data receives the highest weight. Requires smoothing constant of an alpha, and it ranges from 0 to 1. Subjectively chosen, of course. Involves little record keeping of past data. Now, let's talk a little bit about the selecting of the smoothing constant. The objective is to obtain the most accurate forecast no matter the technique. That's the key. That's why we're doing this. We generally do this by selecting the model that gives us the lowest forecast error according to one of three preferred methods. MAD, no, I'm not MAD. It just means mean absolute deviation. MSE, which is mean squared error, and then MAPE, M-A-P-E, which is mean absolute percent error. Common measure of errors for, in mean absolute deviation are MAD. So MAD is calculated as MAD is equal to the sum of actual minus forecast divided by the n. The mean squared error is MSE equals the sum of forecast error squared divided by the n. And of course, the mean absolute percent error, or MAPE, is equal to the sum of whatever 100 times, whatever the 100, actual minus forecasted divided by the actual over n. Comparisons of measures include, for example, the MAD. The meaning of MAD is how much the forecast missed the target. For an alpha of 0.1, for example, and I'm taking this out of table 4.1, which is comparison of measures of forecast error. So your mean absolute deviation shows how much the forecast missed the target. For an alpha of 0.1, and let's say example 4, the forecast for grain unloaded was off by an average of 10.31 tons. Quite a bit. The MSE, or the mean squared error, is the square of how much the forecast missed the target. For an alpha of 0.1 in example 5, the square of the forecast error was 190.8. This number does not have a physical meaning, but it's useful when compared to MSE of another forecast. And then the MAPE, or mean absolute percent error, is the average percent error. So for an alpha 0.1 in example 6, the forecast is off by 5.59% of the average. As in example 4 and 5, some forecasts were too high and some were too low. Now let's look at what's called exponential smoothing with a trend adjustment. When a trend is present, exponential smoothing must be modified. You're going to see that you're going to put this in when you do the exponential smoothing, you're going to look at and put an Excel spreadsheet, and you're going to do the months, the actual demand for the time period. In this case, it's months. The actual demand for each one of the time periods, and then the forecast, for the month 1 through 5. All right, and it'll be like the first one is, the given one. They're always going to give you like a start point. You're going to have the first one, actual demand 100. So then you have the second one, the month. Let's say it's 200. And then third is 300, fourth is 400, fifth is 500. So you're going to start realizing that in order to do the forecasting, you do forecast 1 given. So you just put 100 for that. Forecast 2 would be forecast 1 plus the alpha, all right, using the A minus F that we discussed up, in the past, which is equal to 100 plus 0.4 times 100 times 100, which is also 100. And then it keeps going. The third one will be 140, the fourth one will be 204, and the fifth one is 282. Forecast includes trends, which is FIT, F-I-T. Forecast includes trend. Equals the exponential smooth forecast, F little t, plus exponentially smooth trend, T little t. The formulas are in your book. It also gives you what each one of the subsets are. I recommend you review those as you move on. Now, in the exponential smoothing, this first step is compute the FT for time. The step 2 is compute the big T, or uppercase T, for time. And then this third step is calculate the forecast, which is FIT of time, equals the F plus the uppercase T. Correlation analysis is an important part of knowing how strong is the linear relationship between the variables. The correlation does not necessarily imply causality, where one thing causes the other, it's just correlated. The coefficient of correlation, right, R, measures the degree of association. The value ranges from a -1 to a +1. Now let's talk about something a little bit less mathematical. Goods and services selection. Organizations exist to provide goods or services to society. Great products, of course, are the key to success in any organization. The same thing with good services. Top organizations typically focus on core products. Customers buy satisfaction, not just a physical good or particular service. Fundamentals to an organization's strategy with implications throughout the operations function. Goods and services selection are limited and predictable life cycles, require constantly looking for, designing, and developing new products. It utilizes strong communications among consumers, the customer, product, processes, and suppliers. New products generate substantial revenue. Let's think through about limited and predictable life cycles that require constant looking for and designing and redeveloping new products. How about our cellular phones? You can see that there is a limited and predictable life cycle, and they're all pushed to see how they can make it more, if they're improved, better cameras, great communication, and good operability. The objective for making a decision on a product is to develop and implement a product strategy meeting the demands of the marketplace with a competitive advantage. So let's look at some product strategy options. Differentiation. How different is the product as compared to other products? Low cost, like let's say Taco Bell. and rapid response to the growing market needs. So we say Toyota. Product life cycles may be any length from a few days to decades. The operation function must be able to introduce new products successfully. In the life cycle and strategy, there's the introduction phase. These are fine-tuning may warrant usual expenses for research and development, product itself, process modification, enhancement, and supplier development. The growth phase includes product design begins to stabilize, effective forecasting capacity becomes necessary, adding and enhancing capacity may be necessary also. In the maturity phase, we have competitors that are now established. High volume, innovative production may be needed, improved cost control, reduction in options, and paring down a product life. When we enter the decline phase, we understand that unless the products makes a special contribution to the organization, you must plan to terminate the offering. So let's define what a product is, at least from the OM perspective. The first definition in terms of functions. Rigorous specifications are developed during the design phase. Manufactured products will have an engineering drawing, and of course the bill of materials, or BOM, lists the components of a product. That's how you define a product in operations management. It's not just saying it's a widget. You have to define the definition in terms of what does the widget do, give it specific, rigorous specifications, and for the design phase, etc. Product documents include engineering drawings showing dimension, tolerances, and materials. You've seen many of these when you open up the technical manual. Shows codes for group technology. Bill of materials is a list of components, quantities, and where they're used. Shows the product structure. Now, the documents for production include the assembly drawing, assembly chart, route sheet, work order, and the engineering change notices, also known as the ECNs. The assembly drawing shows exploded view of products. Details relative location to show how to assemble the product. The assembly chart shows what the sequence are, what the line subjects are, where are the nodes, and how are they integrated in the nodes. It identifies the points of production where components flow into sub-assemblies and then ultimately into the final product. The route sheet lists the operations and times required to produce a component. And the work order. These are instructions to produce a given quantity of a particular item, usually to a schedule. The engineering change notice are a correction or modification to a product's definition or documentation. For example, engineering drawings or the bill of materials. Quite common with long product life cycles, long manufacturing lead times, or rapidly changing technologies. The next topic we'll go under is the application of decision trees to product design. They are particularly useful when there are a series of decisions and outcomes that lead to other decisions and outcomes. The procedures include all possible alternatives and states of nature, including doing absolutely nothing. It enters payoffs and end of the branch. It determines the expected value of each branch and prune the tree to find the alternative with the best expected value. So why do we use linear programming? That's my favorite topic, so we're going to go in there. It's a mathematical technique. That's why I like it. To help plans and make decisions relative to the trade-off of necessary to allocate resources. We'll find the minimum or maximum value of the objective, and it guarantees the optimal solution to the model formulated, assuming that the mathematical data that you're using is relative and pertinent. So let's look at some of the applications for linear programming. Scheduling school buses to minimize total distance traveled. UPS does that also. Allocation of police patrol units to high crime areas in order to minimize response time to 911 calls. I did that for quite a few years. and scheduling tellers at banks so that needs are met during each hour of the day while minimizing the total cost of labor. I don't do that, but I make sure that my chief executive officer does that because I'm her chairman of the board. So as you can see, these are important applications that are used on a daily basis in specific job categories. And out of my various careers, I used two out of the various careers. And in the Army, by the way, we used that. We used all of these linear programming applications on everything. The next why we use it is selecting the product mix in a factory to make best use of machine and labor hours available by maximizing the firm's profit. Picking blends of raw materials in feed mills to produce finished feeds combination at a minimal cost, and determining the distribution system that will minimize total shipping costs. Developing a production schedule that will satisfy future demands for a firm's product and at the same time minimize total production and inventory costs. Allocating space for a tenant mix in new shopping malls so as to maximize revenues to the leasing company. Now that we've done some of the applications of the linear programming, let's look at some of the requirements on the linear programming problem. The first one is the linear programming problems seek to maximize or minimize something, usually a profit or a cost, expressed as an objective function. It is the presence of restrictions or constraints limits the degree to which we can pursue our objective. There must be alternative courses of action to choose from. The objective and constraints in linear programming problems must be expressed in terms of linear equations or inequalities. Sensitivity analysis in the linear programming include how sensitive the results are to the parameter changes that we inject. Is a change in the value of the coefficient impacting it aggressively or not? It's a change in the right-hand side value of the constraint and making it aggressive change. In the sensitivity analysis, we also have what's called the trial and error approach. And then there's the analytic post-optimally method. So when we look at the changes in resources, the right-hand side values of constraint equations may change as resources availability change. The shadow price for a constraint is the improvement in the objective function value that results from a 1 unit increase in the right-hand side of the constraint. Shadow prices are often explained as answering the question, how much would you pay for 1 additional unit of a resource? Shadow prices are only valid over a particular range of changes in the right-hand side of the values. Sensitivity reports provide the upper and lower limits of this range. Now, when we look at the changes in the object function, we see that a change in the coefficient in the objective function may cause a different corner point to become the optimal solution. The sensitivity report shows how much objective function coefficients may change without changing the optimal solution point. So let's look at solving minimization problems. It's formulated and solved in much the same way as maximization problems. When you look at the graphical approach in the ISO cost line it's used, the objective is to move the ISO cost line inward until it reaches the lowest cost corner point. This concludes our topic for this week. I hope you've enjoyed it, and we will see you next week. Thank you.